My name is Max Kreil. I'm an Associate Professor at the Monash Biomedicine Discovery Institute based at Monash University. And my group actually works on the biosynthesis of antibiotics. And the reason we're interested in this is because antibiotics are a very important class of compounds that we use in the clinic to help contain infections. But unfortunately, due to the increase in resistance, what we're seeing now is that bacteria are starting to overcome these last resort drugs, and we need to come up with some new ones in order to overcome this. The reason that is the case is because bacteria themselves are fighting a constant battle against the use of antibiotics, because antibiotics have been around for millions of years and are actually used by bacteria to fight other bacteria. And so what this means, of course, is that as these bacteria become resistant to the drugs that we use, we need to find ways to change this. What we also need to do is to find ways that we can change it in a way that we can also produce them at scale. Because one of the problems is that most of the antibiotics we use, particularly peptide-based, are actually produced by bacteria themselves. And that means that what we have to do is understand how these processes work if we're going to understand how to make new compounds. And so what at the heart of the synthesis that we work on is actually a process called non-ribosomal peptide synthesis. And this is quite unusual. It's very different to the system that builds most of the peptides and proteins that are found in your eye. Actually, it makes very small peptides, but they're highly diverse. And what we're trying to do is understand how this process works so we can then design new antibiotics in order to fight against these resistant bacteria.